Okay, good day. This is Honors Algebra 2. This is our blended learning review for March 3rd, 2023, factoring quadratics and the quadratic formula. We're going to factor some quadratic expressions when a is not equal to 1, and then we are going to use the quadratic formula to solve some quadratic equations. So, what does that look like? Basically, if you have a quadratic where you have an a value that is not equal to 1, what you're going to do is you're going to multiply that a and the c, and then you're going to find two factors of that multiplication that also add up to this b in the middle. And in both instances, these two numbers here and these two numbers here, they should both be the same. And then we're going to replace bx with the sum of those values. They'll have x's in it as well. We'll group the first and second pair of terms, and then we will factor something common from each pair, and then we will factor the same group. So what does that look like? Well, here is an expression that I have, and I see that the a value is equal to 2, so I'll come over here and I will say that AC is going to be, in this case, 2 times 3, which is 6. So I need two values that when I multiply, I get 6, and when I add them, I get -7. So if I'm adding two numbers to get a negative, and I'm multiplying those two numbers to get a positive, both of these numbers are going to have to be negative. And so fairly quickly, I see that if I go -1 times -6, and I go -1 plus -6, I will get +6 for the product, and I will get -7 for the sum. And so what I'll do with that is I will rewrite this expression. I have my 2x squared, that's that. And I will rewrite this as -x and then -6x, and then it will be +3. And so this -7 right here has been replaced with -x minus 6x. And the next step, it says go ahead and group those values. So I'll go 2x squared minus x. And then when I group this second one, because I'm going to have a negative, I'm changing that sign to +6. So I have to change the sign of the 3 as well. And so now I want to try and factor something out from each term. And so I look at this expression here, what's inside this parentheses, and I see that I have an x squared and an x, and just this 2. So the only common factor to these two terms is going to be an x. And so when I divide 2x squared by x, I get 2x. And then when I divide x by x, I get 1. Here I see a 6x and a 3. I can factor out a 3. That'll give me 2x minus 1. And I feel very confident in what I'm doing so far because what's inside these parentheses is the same. And so just like I factored out an x from this term, and just like I factored out a 3 from this term, I'm going to factor out a 2x minus 1. So 2x minus 1. And then I'll just bring these two numbers down and say x minus 3, and that is the factored form. The next thing we're going to do is talk about solving using the quadratic formula. And if you recall, if ax squared plus bx plus c is equal to 0, then the value for x that solves this equation will be -b plus or minus the square root of b squared minus 4ac all over 2a. And so how will I use that? Well, here's an expression. And you'll notice right away that it's definitely not in ax squared plus bx plus c equal to 0 form. I have to move these two terms to the other side. So I still have that 2x squared on this side, but when I bring this -2x over, it'll become +2x, and when I bring this 6 over, it'll become -6, and that'll be equal to 0. So this value here is my a, this value here is my b, and this value right here is my c value. So when I go to plug into the quadratic formula, I'll have x is equal to -b is 2, or b is 2, so -b will be -2, plus or minus the square root of b squared, so 2 squared, minus 4 times a, which in this case is 2, times c, which is -6, all over 2 times 2, because that is the a value. So now it's just a matter of simplifying. So I have my x, I have my negative 2, I have plus or minus, and so 2 squared is 4. Negative 4 times 2 is negative 8. Negative 8 times 6 is 48, plus that first 4 will be 52, and that will be all over 4. And so now I need to check to see, can I simplify this 52? Well, I do notice that 4 divides 52 13 times. So 4 times 13, and 4 is a perfect square, so I'm looking for perfect squares that divide that 52. And so I can reduce this. I go negative 2 plus or minus. The square root of 4 is 2. I can't take the square root of 13, so it has to stay, and that's still all over 4. Now I look, I have 1, I have 2, I have 3 terms. All of them are even, so I can factor out a 2 from each of those, and that'll give me negative 1 plus or minus the square root of 13 all over 2. And since 13 is prime and there's nothing else that cancels, this is going to be my final answer. All right, I hope that was short and sweet enough for you. Please get the practice work that you were given yesterday done. I hope you have a great Friday and a great rest of your weekend. See you on Monday. Goodbye.